Hi, and welcome to ArcGIS Online Spatial Analysis. There's 4 of us presenting today: Jan, a product manager, myself, Sarah, Sharmistha, and Amanda, both product engineers on the geoprocessing team. Today we're going to talk about analysis. We're going to start with the Spatial Analysis Toolbox in Online and the tools available. Then, 2 new ways to analyze: ArcGIS Image for ArcGIS Online and ArcGIS Notebooks. Throughout the presentation, we'll show demos of the software with real-world applications. We'll have time for questions at the end and be sending polls throughout the session. We all know that analysis is an important and powerful part of our GIS, and at the core of what many of us do. The analysis tools in ArcGIS Online give us a simple way to analyze a variety of data. Importantly, it's hosted in the cloud, so there is minimal overhead and management for you. You're able to start working and finding answers to your questions quickly. With the integration with WebGIS, you're able to create data products, web maps, and story maps to share results with your organization and drive decisions making and change. We'll talk about what's available through every organization, as well as additional options and ways to extend your analysis. For that, I'll hand it over to Jan.
Thanks, Sarah. In this section, I'm going to introduce some basics of analysis tools in ArcGIS Online. First, what is it? ArcGIS Online spatial analysis are tools hosted in the cloud by Esri, which you can apply to geospatial data, including your own data and data you have access to. These ready-to-use tools are designed to provide a user-friendly experience so that anyone in the organization can use them. The approach we took for the online analysis tools is to identify a set of common geospatial problems and provide the solution-based workflows to solve these problems. It's about using spatial analytical techniques to discover patterns in your data, how they are related, and therefore to gain additional value from your location data. We're really excited that the web has brought us new ways to deliver spatial analysis which were not possible before. One of these new patterns we see is to combine analytical services with curated, authoritative content. For example, using this pattern, you can now quickly generate a viewshed or watershed without having to collect, maintain, or update terabytes of data on your local machine. The online analysis tools are currently accessible only in the Map Viewer Classic. Of course, we are already working on making them available in the new Map Viewer. Sarah will talk more about that in the later session. To get an idea on how to apply ArcGIS Online analysis tools to solve a real-world problem, I'm going to pass it over to my colleague Amanda for a software demonstration.
Hello, I'm Amanda from the Online Spatial Analysis team, and today I'll be showing you some of the ways that you can use the analysis tools available in ArcGIS Online to answer a variety of questions and turn data into actionable information. First, I'll explore how we can find out what campgrounds we should target for a program to raise awareness to reduce the spread of invasive plant species in the lower peninsula of Michigan. To start, I'll search in ArcGIS Online to look for a layer of campgrounds in Michigan to add to my map. I'll add both the regular campgrounds and those on state forest land. Then I'll browse the extensive collection of data available in the Living Atlas to find a layer of invasive plant species. In my map contents, I'll turn on my campgrounds layer and zoom to it, and then center my map on my study area in the lower peninsula of Michigan. I want to treat both campground layers as one layer, so I'll use the analysis tools to do some data management. Under the Analysis tab, I'll browse to Manage Data and choose the tool Merge Layers. In the tool, I can click the information icon to learn more about it. I'll select each of the campground layers as my inputs. I can click the info icon to find out more about each parameter, and I'll decide to add fields to match. The input values from these fields will now be stored under the same field in my output layer. I'll provide a unique name and then run the analysis. Once all my campgrounds are in one layer, I want to find which of these campgrounds I should target for my invasive species initiative. I will use Find Existing Locations to find existing campgrounds that meet certain criteria. I'm concerned about people who may come in contact with species during recreational activities and may inadvertently transport seeds, so I'll look for campgrounds within a 3.5-mile radius of known invasive species locations. I only want fairly current data, so I'll specify that the invasive species observations must have occurred in 2010 or later. As you can see, we can use this tool to combine spatial and attribute queries in one go, combining where and what statements together. I'll keep it as an and since I want to query both statements and both of them to be true. I'll add another unique name and again run analysis. With our results, we can see where we should pilot our invasive species initiative. Thanks to data from the Living Atlas and just 2 analysis tools, we have reduced the potential campgrounds from 153 to only 10 campgrounds where campers will be most likely to come in contact with invasive species, making it a much more manageable program to implement.
Thanks for the great demo, Amanda. So what tools are available currently? As Amanda showed in her demo, you can access the tools from the Analysis tab on the Map Viewer Classic. The online analysis tools are grouped into 6 categories, broadly related to what you wish to do. Let's quickly go through each one of these categories. First are the summarized data tools. This group of tools calculate summarized statistics for features and attributes. It also includes the Join Features tool, which allows you to join attributes or features from one layer or table to another, a very popular use case for many applications. The next category is Find Locations. These tools find features that match a number of criteria that you specify. For example, perhaps you would like to find vacant parcels within half a mile of a river inside of a census tract boundary. The Data Enrichment tool helps you to acquire additional information for your existing data. For example, in order to plan for a new store location, you might want to have the information about the demographic profiles for all the candidate locations. The tools in Analyze Patterns category help you identify, quantify, and visualize spatial patterns in your data. For example, you can use the Calculate Density tool to estimate and visualize patterns of crime incidents or risks of forest fires. The proximity tools help you answer one of the most common questions in spatial analysis. What is near what? You can use Create Buffer to apply a straight line distance around the feature. We also have tools that allow you to take a street network into consideration, such as Create Drive Time Areas. The day-to-day management of spatial data is an important task. Often before analysis, data needs to be processed. The managed data tools can help with this process. Now, what data can be used as input for online analysis tools? The good news is that we support a wide variety of data types. The input data can be hosted features in the cloud, including the rich content in Living Atlas. They can be files like CSV, shapefile, or file geodatabase. In addition, we also support KML, GeoRSS feed, and many more. A side note here, You don't have to add the data to your map in order to use it as an input for analysis. You can use Choose Analysis Layer option that is built in with each analysis tools to browse and select any layer you have access to. Esri's Living Atlas provides ready-to-use layers containing boundary and demographic information for different parts of the world. In addition, the data comes from authoritative sources and are frequently updated. You can leverage this great content in your online analysis workflows. For ArcGIS Online spatial analysis tools, we took one step further and created a collection of Living Atlas analysis layers. These layers are integrated with all our analysis tools and are optimized for use with our tools. So, what do you need in order to use the online analysis tools? Since the tools are part of ArcGIS Online for organizations, you need to have a subscription to an organizational account. To use analysis tools, you need to be a creator user type, a publisher role, and with the right privileges. In addition, the use of the online analysis tools does consume credits as we are using a series of ArcGIS Online provided services. Now, from where can you access online analysis tools? For analysts who prefer to use the tools out of the box, the analysis tools are available in ArcGIS Online Map Viewer Classic. The tools are also available in ArcGIS Web App Builder as analysis widgets. This is a quick and easy way for you to create a web application using the analysis services. If you are an ArcGIS Pro user, the hosted analysis tools are available in the ready-to-use tools. For those of you who like to develop your own web applications that consume the online analysis services, you can use our REST API, such as ArcGIS API for JavaScript. The online analysis tools are available in ArcGIS API for Python, which is a Python library for working with maps and spatial data powered by WebGIS. Those tools can also be added to ArcGIS Notebooks. In ArcGIS Notebooks, you can use ArcGIS API for Python, ArcPy, and popular open source data science libraries all in the same place. You can also customize and extend functionalities in Web App Builder using HTML and ArcGIS API for JavaScript. Now let's watch a demo. This demo applies a combination of elevation, network, and geoenrichment services to predict which way lava will flow, to find out if the lava flow will cut off access of the areas, and how many people may be affected. Here you're looking at ArcGIS Online Classic Map Viewer with a web map of Puna District in Hawaii Island. In May 2018, more than 20 fissures have opened up in Puna District, which were spitting magma and gas. These points on my map are recorded locations of the fissures openings. The first thing I would like to know is, which way will the lava coming from these fissures flow? The next question I would like to answer is, how many people may be affected? Then I would like to find out, do these flows have the potential to cut off access to part of the island, and which part of the island will be affected? Lava, like water, tends to flow downhill via the part of least resistance. Because of this, we can use the Trace Downstream tool available under Find Locations. So from Analysis tab, I'm going to Find Locations and Trace Downstream. The input will be my fissures locations, and then I'm going to go ahead and run the analysis. Now we can see the results from the Trace Downstream tool. It shows the possible lava flow routes to the north, east, and southeast of the vents. Also displayed on the map are the emergency shelters provided for the local residents. Here we can see the service areas of the emergency shelters based on a 15 minutes drive time. As we know, the predicted lava flow routes have the potential to cut off a portion of the Puna district. Let's see how the lava flow path will affect the service areas of the emergency shelters. To generate the service areas for the emergency shelters, we use the Create Drive Time Areas tool under Use Proximity category. To understand the impact of the lava flows, we'll specify the line barriers to be predicted lava flow paths. And run analysis. Now, this is the resulted surface areas layer with the lava flow path set as a line barrier. Compared to the service areas without any barriers, we can see that the areas colored in yellow on the map are now cut off from the 15 minutes drive time of any emergency shelters. Next, I would like to find out how many people may be affected by this. How many people may be cut off from access to the emergency shelters? First, let's use the overlay tool to derive the area where people would not be able to drive to the emergency shelters in less than 15 minutes. Basically, we're going to erase the drive time areas with barriers from the drive time areas without barriers. The output from the overlay layer tool shows the area where people will not be able to drive to the emergency shelters in less than 15 minutes. Now we can use the enrich layer tool to find out how many people are affected. When I click the Select Variables option, I'll be able to see the data browser. We can select the total number of population living in the area, as well as the total number of housing units. After we run the Enrich Layer tool, from the result, we can find out what's the total number of people living in the area and the total number of housing units. That concludes my part of the presentation today. And now I will pass it to Amanda again for another demonstration of using online analysis tools. She will also show you how to create a web app consuming analysis tools using Web App Builder.
Thanks, Jan.
Let's say I'm an advocate for active transportation who lives in Pasadena, California. I'm concerned about pedestrian and bicycle safety, and I want to petition my local government to enact some safety measures. First, I'm going to find some open source accident data from my local community, which I can open in ArcGIS Online. I'll sign in and open my data in a new map. This data includes all kinds of accidents, but since I'm interested in active transportation, I'm going to filter it to only show accidents with either pedestrians or with bicycles. I'll make sure that my filter expression says any of the expressions because I want to see accidents with either pedestrians or bicycles. I'll also add another layer for Pasadena from ArcGIS Online to show the boundaries of the city where accidents could occur. Once I add the layer, I want to do some analysis to know if there's any significant clustering that's happening. I can see the analysis button because my user type has spatial analysis privileges. I know I want to spot patterns, so I'm going to use Find Hotspots tool. I'm going to analyze the counts of collisions within a hexagon grid and use my city boundary to indicate where data could be recorded. Even though I'm analyzing almost 1,500 features, this analysis will use less than 1.5 credits. I'll uncheck Use Current Map Extent because I know my data is only for Pasadena and I don't want to miss any outliers. Once the analysis completes and the result is added to the map, we'll be able to see areas of spatially significant clustering. The red hex bins show us that there is spatially significant clustering of accidents happening in the downtown area. I can find out more information about the statistics by clicking the Show Result icon under the result layer. I'm also concerned about where students using active transportation to get to school may be at risk. I'll use the Summarize Nearby tool to summarize the number of accidents near schools. From within the tool dialog, I can find a layer to analyze that isn't on my map yet. I'll find a school layer from ArcGIS Online and choose an option for the schools themselves from Pasadena City. Now we'll be summarizing the traffic collisions near the school. Instead of straight line distance, let's leverage the road network data that's built into the tool and use walking distance, which accounts for roads the pedestrians can travel. We'll use a walking distance of 0.05 miles and we'll run our tool. With our results, we can see which schools may need more safety measures, and policymakers can prioritize these zones over zones that are already relatively safe. Now, say we want to contact the principal of each school to discuss a safe travel initiative. Well, I've downloaded a CSV of the contact information for each school from the school board website. Now I can just drag and drop that CSV into my contents and add as a table. I can then use Join Features to add this information to our summarized collisions layer. I'll use an attribute join, so the contact information will be added where the school name matches the name in the summarized collision layer. I'll provide a unique output name for our results. As you can see, adding this information will barely use any credits. Now I can run the analysis. Once the analysis completes, we will have features that have both the accident count nearby the schools and the contact information for the principals. This will make it easy to get in touch with principals at the schools with high traffic risk. Now that we've assessed the traffic risk throughout the community, I'll save this web map as a visual reference by providing a unique name and some tags. With that, our traffic safety analysis is complete. Now, let's say we wanted to encourage principals or others in the community to be able to recreate similar analyses. We might want to update the symbology for the schools to make them stand out a little bit better from the collisions. So let's do that. And we'll add the collisions back to our map and save our map again. Now we can share this map and we'll share it as a web app. Using Web App Builder, you can very easily build powerful GIS apps that run on any device. And the best part is, there's no coding required. We can use the easy templates provided by Esri and then configure the widgets that we want in order to choose what features we want to expose. In this case, I'll choose Analysis, and I can browse our existing tools to embed them in a web app. I'll save it, and then I can launch the app and preview what it would be like for a user to use it. So now say I'm a principal at a school, I can use this web app to recreate the analysis by using the Summarize Nearby tool, which we can see looks very similar to the UI that we see in Map Viewer Classic. This time I'll set our summarized distance to be walking time of 5 and 10 minutes to figure out the amount of traffic risk for my students within a 5 and 10 minute walking radius. I'll run the analysis. And we can see a result on our map, just like that. Web apps let you leverage the same power of analysis, but to a different type of audience and through different devices.
Now I'll hand it over to Sharmistha to talk about ArcGIS Image for ArcGIS Online.
Thank you, Amanda. The new ArcGIS Image for ArcGIS Online provides hosted imagery capabilities along with visualization and raster analytics in the cloud. With ArcGIS Image, you can extract and share insights from image and raster at a local or a global scale for better decision making. You can host, stream, and leverage imagery and raster data in your organization without having to maintain any infrastructure. This is a secure, scalable, and performant cloud environment. As Sarah mentioned previously, ArcGIS Image is a software as a service and is available as an ArcGIS Online extension. In ArcGIS Image, 27 tools in 8 categories and more than 150 raster functions are available from the Analysis tab. Some of these tools and functions are for deep learning, enabled with GPU support. These tools and functions support tiled and dynamic imagery and feature service as input and output. You can chain multiple raster functions together to create a complex model using raster function editor. You can then save it as a template and share it across desktop, enterprise, and ArcGIS Online. As other ArcGIS Online tools, you can pre-estimate the credits before running the functionality. All these analytical capabilities are currently available in the Map Viewer Classic. It will also be available in Map Viewer in the future release. Tools and functions in ArcGIS Image let you solve different kinds of problems, like tools in summarize data, calculate statistics like mean for a raster layer within the areas of another data. Analyze patterns let you identify and quantify spatial patterns in your data. The use proximity tools help to answer some of the most common questions like what is near what or what is the most optimal path. The analyze terrain tools and functions create slope, aspect, hillshape, and so on. The deep learning tools are used to detect or classify specific features in an image or to classify pixels in a raster dataset using artificial intelligence machine learning method. The multidimensional analytical tools are for performing analysis on scientific data across multiple variables and dimensions like time and depth. The change detection functions perform change detection between raster datasets. Another great functionality is raster map algebra, which is a simple and powerful way to perform analysis. Additionally, there are many data management tools to prepare and manage your data for analysis. These and many more raster analysis capabilities are available in ArcGIS Image. With all these analytical capabilities, we can now solve different kinds of real-world problems. For example, as we know, last year approximately 10,000 fires burnt more than 4.3 million acres in California. We can leverage various raster analysis tools and functions to understand the impact and severity of wildlife fire. We can analyze effects of climate change and rise in sea surface temperature that can increase coral stress over time. Perform ecological model to predict or analyze loss of habitat of species. We can also analyze how land cover has changed in the past years and predict future changes. We can detect shipwreck using deep learning and delineate watersheds and find its different characteristics. And solve many other complex problems as you can see here. Now let's look at an example to analyze watershed characteristics using ArcGIS Image. In this example, I'm trying to determine watershed characteristics in southern Utah, near the Zion National Park, an area with a history of dangerous flash floods. To do this analysis, I'm going to use slope and flow accumulation to calculate compound topographic index, also known as topographic witness index, and then summarize the index within watersheds. I have flow accumulation raster and a watershed boundary on my computer, and I want to host them on ArcGIS Online. Now I'm going to create a dynamic imagery layer from the flow accumulation raster. Let me show you how. I'll click on Create and Imagery Layer. Images can be hosted as static tiled imagery layer or dynamic imagery layer. I'm selecting dynamic imagery layer so that I can do on-the-fly processing. I'm going to select one image, in this case, for the layer configuration. I can also configure the properties, but for now I'll keep it as default. And then I'll browse to my dataset. Next, I'm going to fill out the item description, add tags, and create to upload the data. I also uploaded the watershed as a feature service. Now, fast forwarding a few minutes, all my dataset are now loaded in ArcGIS Online in this map and is ready for analysis. I have added the terrain data, which is a digital elevation model available from the Living Atlas. And this is my flow accumulation raster. Now the first step of my analysis is to calculate slope. I want to use the slope raster function to do this. I'll click on the Analysis tab and then on the Browse option to use the slope raster function to do this. I'll go to System and search for slope. I'll select it to open the raster function dialog. I'm specifying terrain data as my input DM. Once I click on the Show Preview, I can see the slope output preview on the map. I can also click on the Show Credits before running the raster function. Now to compute the compound topographic index, I need to perform additional analysis besides slope. So I'll not run each of the function individually. Instead, I'll calculate the compound topographic index using a map algebraic expression. I can create this equation using the raster function editor by chaining several functions together. I've already created the template. Let's take a look at it. If you want to create one from scratch, you can drag and drop available system raster functions from this window to the editor. Here, I'm calculating the slope of the TEM, adjusting for flat areas, converting the slope decrease to radian, and then calculating the tan of the slope. Next, I'm dividing the cell size by the tan of the slope and multiplying it with adjusted raster flow accumulation. And finally, I'm finding the natural logarithmic of this expression, which is the compound topographic index. Now, I can just run this template. Here also I can preview and estimate the credit. Now I have already run the template. And this is how the topographic index looks. You can see the variation of wetness across the study area. Now to understand the distribution of maximum wetness across the watershed, I'm going to run the Summarize Raster Within tool from the Summarize Data category. I'm going to select Watershed as my zones, define the zone field, choose Compound Topographic Index as the layer to summarize, and choose Maximum as the statistics to calculate. I'll make sure that I'm using the current map extent, and I'll run the analysis. From the Summarize Raster Within output, you can see some variation within the watershed. The La Varkin and the North Creek watersheds are relatively drier, whereas the East Fork Virgin River has more moisture content. That's how you can upload data and access raster analysis tools and raster functions from the Analysis tab. You can also create a template using raster function editor. To calculate compound topographic index, I used a mathematical expression using a DM and flow accumulation as inputs. I then summarized it within Watershed to better understand the distribution of wetness across the region. To learn more about ArcGIS Image, check out the session on ArcGIS Image for ArcGIS Online and Introduction. Now I'll pass it to my colleague Sarah to introduce you to ArcGIS Notebook. Over to you, Sarah.
Thanks, Sharmistha. Now I'd like to introduce ArcGIS Notebooks. ArcGIS Notebooks are a way to extend your analysis to automate and promote reproducibility and transparency and share your workflows. Notebooks allow you to perform analysis with the same tools we've previously talked about. They're integrated with your WebGIS, so you can do things like browse to your datasets or tools. Lastly, you can use Esri's Python resources such as ArcPy and the ArcGIS API for Python, but you also have other Python libraries that you can use, for example, pandas. Using notebooks requires similar user types and roles as spatial analysis. In addition, there are privileges to create and edit notebooks, schedule them, and more advanced functionality. When you share a notebook, others can view and create a copy of it. Notebooks really shine with a demo, so I'm going to hand it over to Amanda.
AirNow is a program of air quality monitoring stations deployed across the USA. I've downloaded some of their data and shared it in my organization. Now, let's look at how we can use ArcGIS Notebooks to manage and analyze this air quality data and turn it into meaningful information. Because I am a creator user type, and I've been granted privileges to create and edit notebooks, I can see the Notebook tab. Let's select it to get started. Here, we can browse existing notebooks, but I want to create a new notebook. If you're not familiar with notebooks, they're like a workbench where you can bring in a variety of tools in one location. Every ArcGIS notebook automatically loads the ArcGIS API for Python tool, which will allow us to invoke general mapping and analytic capabilities. We can also bring in other modules and tools from Python, such as Pandas, Seaborn, and ArcPy, which give us access to additional ways to explore and manage our data. We can even import machine learning toolkits, such as scikit-learn and TensorFlow. Now that we have our tools loaded, let's add our data. Clicking Add, it's easy to find and add your content in this familiar interface, and the notebook adds the necessary code. Now that I've added my air quality monitoring stations, we can also browse all the layers in the Living Atlas. I'm going to add a layer of administrative boundaries that can help us in our workflow. And we'll add it with a new item name. Now, let's plot our air quality stations layer on a map. Notebooks is great because it allows us to create on-the-fly visualizations of our data, such as a map that we can interact with and explore. Since we loaded the Pandas module, we can also work with this layer as a table and look at the attributes contained in the layer. One of the attributes in this layer is particulate matter in the air, which can impact people with breathing conditions. Let's take a look at the distribution of these values in a plot using Matplotlib and Seaborn. We can see that there's an extreme negative value, which actually corresponds with stations that are missing air quality data and that are coded as negative 999. So let's clean this data a bit before we use it. Now that it's cleaned, if I re-execute the code for our chart, we'll see a much cleaner distribution that we can work with. To help us understand how these particulate matter's values may impact vulnerable populations, let's bring information in from the Environmental Protection Agency's website. We can use these notes to help us present our finished analysis. And from the notebook, we can even navigate the web page to investigate the health effects of air pollution and justify some intervention measures. Now that we've loaded, cleaned, and documented our data, we're ready to do some analysis. It's easy to find and incorporate analysis. Just click Analysis and navigate the same categories we've seen before. This time, I want to interpolate the air quality between stations, so I'm going to load the Interpolate Points tool into our notebook. I'll specify the inputs, providing an input layer, an analysis field, in this case particulate matter, a bounding area, our states, and an output name. We'll set the output to a Python variable that can be referenced in the rest of our notebook. With the tool running, I'll also set up an additional cell to load the output into our map. The asterisks indicate that this section of the code is in progress. Once the interpolation is ready, we can view and interact with the results in our map, looking for where vulnerable populations may be impacted by poor air quality. To document what is happening in our code, we can also do things like add markdown. Then we're ready to share it with our team. First, let's save the notebook. We'll give it a unique name some tags. And then we'll be ready to share it within our organization. You can see that our newly created notebook has been shared to the group and is ready for collaboration. If this was an analysis we want to repeat monthly, we could use the tasks option to schedule this workflow every month. As you can see, ArcGIS Notebooks makes it easy to automate data management and analysis. For ideas on how to get started with your own data, you can check out the collection of Esri sample notebooks. We can't wait to see the notebooks you put together and share.
Thanks, Amanda. Now we're ready to wrap up. Here's an overview of the work we've done and where we're going. We continue to add new functionality at each quarterly release. This includes new tools, enhancements to existing tools, and more. ArcGIS Image for ArcGIS Online and Notebooks are two new ways you can further enhance your analysis workflows. We didn't discuss it today, but we know that charting is a critical component of analysis. That is recently added to the new map viewer. In addition, the team is actively working on bringing analysis to the new map viewer alongside the new charting capability. To summarize what we've seen today, ArcGIS Online is an easy way to get started with powerful analysis. We saw many demos of different applications and workflows using analysis, automation, and imagery. All the tools include documentation, and we have blogs and other resources to help you get started. We hope you've learned a lot more about analysis and the capabilities available, and we're excited to hear your feedback and questions. Here's some additional resources to start learning and get started, and thank you so much for attending.